Can everyone see my screen?
We do.
Okay. That's interesting. I don't see it on the Zoom call. Okay. So my name's Jeff Olivier. I'm going to be talking about Google's journey to adopt DAOS with its parallel store service. Some of the challenges and issues that we've faced over the last couple of years, or actually several years, I think. So first of all, I'm going to talk about what's unique about the cloud. Talk about some of the networking challenges that we've had. That's probably been our #1 issue. And then a few selected deep dives into issues that we've solved or issues that we have, and then talk about some of the DAOS development challenges for us, and then I'll open it to Q&A. So first of all, what is unique about DAOS in the cloud? So the cloud offers us lots of abilities. The main reason people go to cloud is they don't want to deal with all the system administration stuff, and so they expect things to be easy. And we want things to be easy and automated. So all of the repair and administration of a DAOS instance is all automated. In fact, any manual intervention that we have to do is really expensive and is annoying to the customer, it's annoying to us. Restoring service when an outage does happen is the #1 priority. And then debugging is typically done post-mortem. The customer's back up and running, but then we try to figure out what happened. Parallel store is a one-click type of solution. You click a button after some initial setup, and then you have an instance running within a few minutes. Client setup's a little bit more challenging with the Google Cloud Compute environment, but for GKE, it's similar. You can kind of script it to be really easy to set up a bunch of clients, a bunch of client pods to with DAOS mounted to defuse. We have optimized import and export of data to and from the Google Cloud Storage. VMs can be easily replaced. Sometimes that actually happens without our knowledge. A VM gets migrated from one host to another. We only know about it when it fails. And then there's lots of tools for viewing logs and metrics available. Some challenges: placement of VMs relative to compute can be a challenge. Sometimes they get placed in a bad, a different cluster, maybe in a different building, which is really bad for DAOS performance. TCP, it's TCP only. There's no RDMA. We have limited VM shapes that we can use. We're not like Aurora, where you can kind of custom design the hardware and pick everything. You have to deal with what you have. And then also client compatibility can be an issue because we don't control the client side. We provide packages, but the user's kind of on their own. So talking about networking challenges, I won't belabor I won't go through each of these. You can read them, there's links. But essentially a lot of networking issues they manifest as a hang. And since parallel store is mostly a defuse solution, that hang just, the mount point is hung. And that's really bad. And we'll fix an issue, and then the user will try again, and it'll hang again. It's a different issue, but from the user's perception, it's difficult to control there. So that's been a challenge. LibFabric expertise has been a challenge. Both Dee and Sean have really stepped up to dig in and raise our level of expertise, but it's a challenge. HPE and Intel have been really helpful. The LibFabric team at Intel and the networking team at HPE in finding and fixing issues. So just to go through a few things that we've run into over time. So one was with our balanced file config, which is EC2 P1G8. If you write 8 GB, so we had a problem where if you wrote 8 GB files, you'd run out of space with about 30 to 50% total capacity usage. And this was because the placement algorithm doesn't do well if you sequentially allocate the OIDs. So we changed it to do a large prime instead, and we get up to 95% utilization with that simple change. That's something to be aware of for people that don't use DFS. So the firewall problem, I won't go into the details on what a virtual private cloud is, but essentially the default settings for your for your network that you create will allow connections to parallel store, but not connections to ports in the reverse. So the problem is if the user doesn't open all of their ports to the parallel store service, DFuse will just hang. And that's because the bulk transfer so when you send a write, it gets forwarded to a follower target and somebody else in the redundancy group. That node does a bulk transfer, and it basically libfabric will try to create a connection automatically back to the original client port. So we implemented in the firewall feature branch this change to essentially set a fully compatible flag in libfabric that says the client endpoint's behind a firewall. So if the server doesn't have a connection, it'll just reply with an error that allows the client to then ping all of the non-leader targets, at which point it can retry the write, and this time the bulk transfer will succeed because the other targets have a connection back to the client. So repair is an ongoing challenge, probably one of our biggest challenges. So the SSDs have uncorrectable bit error, basically a high uncorrectable bit error rate that prevents, essentially makes ECP 2P1 impractical, because when you need to reintegrate a target or a node, it's likely you're going to hit an uncorrectable bit error because you've lost the data on the target you're reintegrating. And then rebuild will fail and you essentially lost data. We need the checksum scrubber to actually repair errors to make it practical, and it doesn't do that today. And also we've had some issues with scrubber stability. There's occasional crashes that we see. We can't generally replace single targets in a parallel store system. So we need to upgrade target failures to rank failures. It's much easier to just replace a VM than it is to replace a single target. And also we disable degraded mode rebuilds. So we use the delay rebuild property. And so this avoids DRDO space for small instances that are full or relatively full, but also avoids the extra rebuild when you're just going to put in a new VM anyway. So you can basically do one rebuild. It's also a challenge to know what is happening in a DAOS instance. You get a customer complaint and you don't really know what the problem is. You don't have much visibility into what the customer's doing. We've found that metrics are super useful because we have the ability to graph them over time. Particularly counter metrics are more useful than gauges, because with gauges you're sampling a sample essentially, whereas with counter metrics you can just keep updating. You get much nicer graphs that way. We found an issue recently with FIO. Somebody was using a really old version of FIO that was producing 1 byte writes. That's what this graph is on the right. It shows that the average write size is 1 byte. This actually caused an aggregation crash, which we need to fix, but also was able to Google 1 byte writes in FIO and found an old PR that fixed the issue. Sorry. We find logs are useful, but are often overly chatty. And also client-side visibility is always a challenge. We don't have control over the clients. we don't control the client machine, the VMs or the pods. So we've added this client telemetry that allows us to see what's happening. The user has to opt in to that, so that's an issue, but we can at least see write sizes. They're more difficult to see if you only have server metrics because they're split by targets. So lastly, just want to touch on challenges we've had at Google over time. So Parallel Store uses a rapid release model. We try to release a new version of DAOS every 2 weeks to customers' hands. I think we're probably averaging closer to a month at this point, but that's the goal. Google has a really nice pipeline for catching regressions. Problems we have, though, are we still rely much on the upstream testing to make sure that what we're pushing is good, because it's difficult to actually run the upstream tests internally, or nearly impossible to run the upstream tests internally. There's a lot of assumptions made. You could read through that list. RPM builds outside of, sorry, let me back up. So we have automated perf and longevity testing that's really useful. We can see performance over time, and we get notifications if performance has dropped a significant amount. And then longevity testing, there's some bugs that, like, we had a bug recently with ref counting thing that Mike fixed, that where it was essentially overflowing a UID32 and causing an insertion failure. But that only happened after like a week of constant IO on the system. RPMs are difficult to build outside of HPE. I'm trying to address that issue. Lack of CI visibility has been a problem, particularly for people that aren't me and Mike. And currently with the transition, it's been a challenge. It's also difficult we have good internal testing, but it's difficult to move our internal testing into the upstream, primarily because there's lots of tools around doing it internally that aren't available outside. The length of time from PR creation to submission is days long. To compare and contrast that to the typical experience of somebody that's been at Google for a while in doing development inside of Google, you're talking about minutes to hours to get something landed. So that's been a challenge, particularly for engineers that are coming from that environment. And then also new developer onboarding for various reasons, many of the reasons above, but also DAOS is kind of difficult to follow. It's all the things that we know. It's written in C. It's not saying C is dying, but fewer new engineers have C experience. So with that, I'll open it up to any questions.